Okay, this video is to help you review the Unit 4 test. We'll begin by looking at sketching the graph here. The trick on this one really had to do with how you were going to set up your axes. Because the sine of x was defined between negative 2 pi and 0, you really had to count by like pi over 2's or pi's on your axes and just kind of have to deal with 1 divided by pi or kind of estimate those numbers. So when you drew your axes, we could count by pi over 2's. You want to nicely label that. Let's see. So this would be negative pi over 2, and then pi, and then negative 3 pi over 2, and then negative 2 pi. We can do the same on this side. But the range of the sine is from negative 1 to 1, so that's probably fine on the y-axis. And then coming in on the sine, if you think about the sine of negative 2 pi, it is 0. The sine of negative pi is 0, and at 0, it's 0. And then at negative 3 pi over 2, the sine of negative 3 pi over 2 is actually positive 1. And then it comes down like this to negative 1 at negative pi over 2. So there's that side of the graph. And then we know the graph of 1 over x just is kind of a nice little branch. Pi over 2 is about 1.57. So 1 divided by 1.57 is like 1 divided by maybe 1.5, which is 1 divided by 3 halves. So maybe 2/3. So at pi over 2, you're kind of about here. You know, and you can kind of, you know what it's going to look like. 1 divided by 3 is 1/3. Pi is 3.14, so maybe about here. But hopefully you kind of have a sense of what the graph looks like. So you just sketch in a nice little graph there. Okay, now on the next problem, there were several answers for this problem, but hopefully you just kind of didn't deal with the phase shift. You just dealt with these as non-phase shifted. And so if I look at this graph, I can see that it looks like a non-phase shifted cosine. The amplitude is 2. The period is 4 pi. And the formula for the period is 2 pi over b. So you can cross multiply to solve for b here. So you get 4 pi b is equal to 2 pi. Then you divide both sides by 4 pi. And you find that b is equal to 1/2. Okay, and so then you have y is equal to 2 cosine 1/2 x. That would be a nice equation. And on b, we can think of this as a sine curve, not phase shifted, again with an amplitude of 2. Now our period though is 4. So 4 is equal to 2 pi over b. So cross multiply, you get 4b is equal to 2 pi. So b is equal to 2 pi divided by 4, or pi over 2. So we would then write our formula as y equals 2 sine pi over 2x. So there were some other answers for that, but those were kind of the two, what I would consider most straightforward non-phase shifted answers. Okay, the sign of the inverse sine is just going to be u. And the only time that this would be different is if you had like the inverse sine of the sine. And then you just have to make sure that the angle that you spit out is between negative pi over 2 and pi over 2. But in this case, the sine and the inverse sine just undo each other, so you just get, in fact, u. Now, on this one, you have to do a little thinking here. This is your angle theta. So that means that the cosine of theta is equal to u over 1. And cosine, remember, is adjacent over hypotenuse. And so you could think of a right triangle. Here's your angle theta. We have the adjacent u. The hypotenuse is 1. So this will be the square root of 1 minus u squared. or 1 squared minus u squared. And so the sine of theta is equal to the opposite over the hypotenuse, which is just equal to the opposite, which is the square root of 1 minus u squared, where the hypotenuse is 1, or just the square root of 1 minus u squared, if you clean that up there. Okay, so this one was a little bit tricky. You want to think of u as equal to sine theta here, and so you have you would have 2u squared minus u minus 1 equals 0. And then you can factor that as 2u plus 1 times u minus 1 equals 0. Setting each of your factors equal to 0, 2u plus 1 equals 0, so u is equal to negative 1/2, and u minus 1 equals 0, so u is equal to 1. But remember, u is equal to the sine of theta, so you need to figure out where the sine of theta is equal to negative 1/2 and where the sine of theta is equal to 1. And you're on the interval from 0 to 2 pi. So if you just think for a minute, the sine of theta is negative in the third and fourth quadrant. So it'll be negative 1/2 at 7 pi over 6, and then again at 11 pi over 6. And sine of theta equals 1 at pi over 2. So those are your 3 solutions to that one. Okay, so sorry, this got a little silly here. Let me erase that. Okay, coming back. It says find they tell you the sine of theta is equal to 3/5, and theta is in quadrant 1. The sine of negative theta, if you just kind of think about this, remember that the sine of 30 degrees was equal to 1/2. What's the sine of negative 30? Well, that's in the fourth quadrant. That was negative 1/2. So in general, the sine of negative theta is equal to the opposite of the sine of theta. And so we know the sine of theta is 3/5, so here it's going to be negative 3/5. Just a little thinking problem there. To find the sine of 2 theta, you want to use your formula, the double angle formula. Sine of 2 theta is equal to 2 sine theta cosine theta. Now you know the sine of theta is 3/5, so you have to do a little bit of work to find the cosine. So let's draw a right triangle. There's your theta. Sine is opposite, so that's 3, hypotenuse is 5. And then if you do right triangle trigonometry, you should be able to convince yourself that the side adjacent is 4. 25 minus 9 is 16, square root of 16 is 4. Okay, so then the cosine of theta is equal to adjacent over hypotenuse, or 4/5. So we can fill out this formula. It'll be 2 times the sine of theta, which is 3/5, times the cosine of theta, which is 4/5. And so you get 24/25 as your answer. Now, if you wanted to find the cosine of 2 theta, you could use any of the formulas that you know. There's the cosine squared theta minus sine squared theta is one of the double angle formulas for cosine 2 theta. So we already know cosine theta is 4/5, so we would do 4/5 squared minus the sine of theta is 3/5, so we'll do 3/5 squared. So that's 16/25 minus 9/25, or 7/25. Okay. On this problem, the amplitude is this A, this number in front. The period is 2 pi over B, so 2 pi over B is just pi. The phase shift is that pi over 2. And so remember, we always want to start at the phase shift, and we would end at the period plus the phase shift. And we're not really starting or ending, but that's kind of how we set up our axes. And so that would be, in this case, pi plus pi over 2, which is 3 pi over 2. And the midpoint would be the start plus the end. So the start plus the end divided by 2. So this would be 3 pi over 4. So it makes sense to kind of count by quarters here. So 1 quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters, 6 quarters is 3 pi over 2. So this is pi over 4. This is 2 pi over 4, which is pi over 2. This is 3 pi over 4. This is pi, because it's 4 pi over 4. Here's 5 pi over 4, and then 6 pi over 4 is 3 pi over 2. So we're dealing with a cosine with an amplitude of 2. So it doesn't really start, but we kind of imagine that we're starting with the phase shift here. And then its lowest value, this is -2, is right here at pi, and then at 3 pi over 2, and it's 0 in between there. So you should have sort of a nice graph of one cycle. Okay, so on this one's a little bit tricky. You want to factor 3 out of that, and you want to put it in as a negative. So this will be 5 sine. So then we're going to have 3 parenthesis x. Now if we want to make it minus, but it's plus, you're going to have to say minus negative pi over 2, but we factored out 3. So to factor means to divide. So that's going to be pi over 2 divided by 3, which is pi over 6. See, because you do pi over 2 divided by 3, put that over 1, so that's pi over 2 times 1/3, which is pi over 6. So your period is just 2 pi over b, 2 pi over 3, and your phase shift is negative pi over 6. Okay, now to graph two periods of tangent 1/2 x plus pi over 2, I like to consider the cosine of 1/2 x plus pi over 2, because then plus 2 pi, because then I will see where the asymptotes are. So this has a period of 2 pi over 1/2, or 4 pi, and it has a phase shift of negative 2 pi, because it's the plus there is going to make it, you think of it minus a negative 2 pi. And so you would start at the phase shift of negative 2 pi, and you end at the period plus a phase shift, which is just going to be 2 pi. And so it makes sense kind of to count by halves on that. So let's do that. So negative pi over 2, negative 3 pi over 2, negative pi, negative 2 pi. And then pi over 2, pi, 3 pi over 2, and 2 pi. Okay? And so your cosine, remember, would start at its amplitude, which is just 1 here. And I'll just dot this in because this is not really the graph that we're interested in. The midpoint's going to be right here, and then it's going to go here, and then somewhere in between here, let's see, at negative pi, and then at pi, you're going to have just this nice little graph of your cosine. And so that's going to show you where your asymptote should be, because wherever that crosses the x-axis is where your asymptotes for your tangent are. And so your tangent will be 0 in between the asymptotes, and then because it has just 1 is like the amplitude there, you're going to, at pi over 2, you're going to be at 1, and at negative pi over 2, you're going to be at negative 1. So it kind of looks like this. You have some options on graphing the rest of it. You could come in here and you know that it's going to be like this piece of it, and then this is going to be this piece. That's one way to do it. Or you could put in another asymptote if you wanted and draw a complete, one that's a continuous curve. Okay, on these problems you have to remember that the inverse tangent is defined, has a range between negative pi over 2 and pi over 2. So if you think about your unit circle, this is going to be true when you're at negative pi over 6. The inverse sine is 1/2 at positive pi over 6, and the inverse cosine is negative square root of 3 over 2 at 5 pi over 6. Okay. On this one, we know that the tangent of theta must equal 13/5, and tangent is opposite over adjacent. So if we make a triangle, the opposite is 13, the adjacent is 5. So this one's a little bit tricky because you're going to have the square root of 13 squared plus 5 squared. It's not a pretty answer. That is 169 plus 25, which is 194. So this is equal to the square root of 194. And so the sine of theta is equal to opposite over hypotenuse, so 13 over the square root of 194, which if you want, you can rationalize that to be 13 times the square root of 194 divided by 194. Okay, on 11, we can do our trig substitutions. This is going to be the square root of secant squared theta minus 1, which you should remember from your Pythagorean identity that that is tangent squared theta. And so you do, in fact, just get tangent theta. Now, this one doesn't really clean up very nice. This is cosine theta over the square root of cosine squared theta minus 1, which is not, that is negative sine squared theta. So this is cosine theta over the square root of negative sine squared theta, which is not a real answer. So this one is not a good one. I kind of messed up on this one, so I didn't count it wrong for anybody, but if they did this, then that was actually what we were going for. That's all you could do on that one. Okay, find the exact value of sine 7 pi over 12. What I would do on this one is to make 7 pi over 12 into degrees because it's a little bit easier to work with. So we would multiply by 180 over pi. The pi's cancel. 12 goes into 180 15 times, and 15 times 7 is 105 degrees. And you can get 105 degrees, so finding the sine of 7 pi over 12 is the same as finding the sine of 105 degrees, which is the same as finding the sine of 45 degrees plus 60 degrees. And your sum formula for your sine then is sine 45 cosine 60 plus cosine 45 sine 60, which then this is the square root of 2 over 2. The cosine of 60 is 1/2. The cosine of 45 is the square root of 2 over 2, and the sine of 60 is the square root of 3 over 2. So this is the square root of 2 plus the square root of 6 all over 4. Okay, now on 13, we know that we have, let's see, what do we have there? We have the sine of v is equal to 5/13 with v in quadrant 2, and we have the tangent of u is 3/4 with u in quadrant 3. We want the cosine of u plus v. So our formula is cosine u cosine v minus sine u sine v. So what we can do then is we can say, let's see, the tangent of u is equal to 3/4. So tangent is opposite over adjacent. And so if you have a right triangle, you've got the opposite is 3, the adjacent is 4, so that's going to be 5. And then the sine of v is equal to 5/13, which is opposite over hypotenuse. So that would make, we've got angle theta, this is 5 and this is 13. And that's 169 minus 25, which is 144, so that's going to be 12. So the cosine of u, sorry, I should have put u there. Let's make that a u, and let's make this one a v. Okay, so the cosine of u, cosine is adjacent over hypotenuse, so that's going to be 4/5 times the cosine of v, which is adjacent over hypotenuse, so that's 12/13, minus the sine of u. And I didn't have my quadrant thoughts here, did I? I'm in quadrant 3, so for u, the cosine will be negative there. And for v, I'm in quadrant 2, so it's also going to be negative. So both of those are negative. All right, the sine of u is, sine is opposite over hypotenuse, so that's going to be 3/5. Now we're in quadrant 3, so that's going to be negative. And then the sine of v is 5/13. So this is 48/65 plus 15/65, or 63/65. Okay, on 14, we were just looking at these graphs and trying to decide, answer some limit questions. So as you approach -1 from the left, you're looking, here's -1, and you want to look at the y value from the left, you should see that it's coming on to 4. Now, as you approach -1 from the right, the y value is 3. So the limit at -1 does not exist, because in order for the limit to exist, you have to approach the same numbers from the left and the right. Now on D, the limit as you approach 3 from the left, here's 3, approaching 3 from the left is going to be 2. The limit as you approach 3 from the right is also 2, because you can see it's not the function value at 3 is not 2, but the limit at 3 is 2, because you get the same number from the left and the right. So the function value at 3 is actually 1, because that's the point that's colored in there at the point 3, 1. So we have discontinuities at both x equals -1, because the limit doesn't exist, and at x equals 3, because the function value is not equal to the limit. Okay. On 15, I like to think of this in 3 steps. The first thing I would do is find f at a plus h. Well, a here is 2, so this is f of 2 plus h. So this is 3 times 2 plus h squared plus 2 times 2 plus h plus 1. So this is 3. When you FOIL this out, you're going to get 4 plus 4h plus h squared. Distribute here, you're going to get 4 plus 2h plus 1. So this is going to be 12 plus 12h plus 3h squared plus 4 plus 2h plus 1. So collecting, you'll get 17 plus 14h plus 3h squared. All right. And then if you find f at a, f at a, that's equal to f at 2, which is just going to be 3 times 2 squared plus 2 times 2 plus 1, which is 12 plus 4 plus 1, or 17. So now your difference quotient, the limit as h goes to 0 of f of a plus h, well, that's a 17 plus 14h plus 3h squared minus f at a, which we just found to be 17, all divided by h. So this is the limit as h goes to 0. You should see your 17s will cancel. You can factor h out of there, and you'll get 14 plus 3h over h. Your h's cancel, and so when you do a direct plug-in, you do get 14. That's a nice little problem there. Now on number 16, if we do a direct plug-in, we're going to get 0 over 0. So I like to go ahead and rationalize the numerator here. So this is square root of x minus 3. And not rationalize, sorry, we'll multiply by the conjugate. So this is square root of x plus 3 over the square root of x plus 3. This is still over x minus 9. Okay, and when you clean this up, you'll see this is still the limit as x goes to 9. But this is going to be x minus 9 over x minus 9 times the square root of x plus 3, which is the limit as x goes to 9, which is 1 over the square root of x plus 3, which is the square root of 9, which is 3, or 1/6. Okay, now on this one, it's going to be x plus 4 over x plus 4, and then this is going to be 4 over 4. Because when you do a direct plug-in, you will get 0 over 0. So we're just getting common denominator in our numerator. So this is the limit as x goes to 0. So this will be 4 minus x plus 4 all over 4 times x plus 4, and that's all over x. Okay, and then in the numerator, you'll see that your 4's are going to cancel. You get negative x. So this is negative x over 4 times x plus 4, and then you can multiply that by 1 over x, because dividing by x is the same as multiplying by 1 over x, and the x's cancel. And now when you do a direct plug-in, you put 0 in for x, you're going to get negative 1/16. Now, be careful in this one, because if you do a direct plug-in, you'll see that you just get 9 minus 4 over 3 minus 2, or just 5. So you didn't have to do much work on that one. I guess you could have factored it and still would have got the same answer when you did the plug-in, but that was kind of quick on that one. All right, and then for the last problem here, to determine where the function is discontinuous, you just want to look at the limit of the function. So the limit as x approaches 4 from the left, you would look at this top row. So of f of x is going to be 5 times 4. You can just do a direct plug in there and you get 20. The limit as x approaches 4 from the right, that would be, you would pick values to the right of 4, which would be this third row here. So that would be 4 squared plus 4, which is also 20. But and so you do have the limit as x approaches 4 is 20. And the reason that's true is because you approach the same limiting value from the left and the right. However, the function value at 4, f of 4, is equal to 21, which is not equal to the limit as x approaches 4 of f of x. And so, therefore, the function is discontinuous at x equals 4. Okay, so I hope that video wasn't too bad for you. Remember to bring this video with you to, or bring your notes from this to class on Thursday for a nice clean quiz grade. Okay, thanks.